Okay. As I said, it's going to be U substitution. So if we think way back to U substitutions, first thing we did was we chose U. So choose U. And what frequently worked was U equal the inside function. And so I'm going to let U equal 4 pi natural log of x. Then you calculated du. And remember, all that was du derivative dx. So du, and then just taking the derivative that you see there. And so the pi over 4 is just a coefficient, so it just stays there. Derivative of the natural log is 1 over x dx. And then 3, solve for dx. And so what? Multiply both, so that's going to be dx equals 4x, 4x du over pi. Multiply both sides by 4x and divide by pi. Okay, remember one of the things we said back when we were doing U substitutions. When you calculate du, so up here, when we calculate du, you know you're in the ballpark, probably on the right track, if the variable part of du, this 1 over x, if the variable part of du is also in the problem. So this is saying if I want the variable part of du in the problem, 1 over x, that I want an x in the denominator, and there is an x in the denominator. So these were the first basic 3 steps to a U substitution. Make your choice for U, calculate du, solve for dx. And I'm just going to write this down again so it's a little bit bigger. And so this was going to be U. Dx is going to be replaced by 4x du over pi. We've got some canceling here. Those x's are going to cancel. The 4 and the pi are just coefficients, multiplied coefficients, so they can come all the way out. And all I've got left is tangent u du. Now, notice I did not write the 1 in e, and that wasn't an oversight. The 1 and the e are limits with respect to x. This integral is in terms of u. It is wrong to write, really, this is x equal 1. It is wrong to write x equal 1, x equal e. These are limits with respect to x. They do not belong on the u integral. Now, this is just my personal thing. I will put little asterisks there. You won't see that anywhere else. This is my little personal thing. Where that asterisk means integral is now in terms of u. We do not have limits with respect to u. Can't use limits with respect to x. Like I said, those little asterisks are just my thing. You don't have to write them down. You can just leave it blank here if you wish, but you cannot write the 1 and the e. If you write the 1 and the e, or whatever the x limits happen to be, I will take off points because it is wrong. Even if you manage to get the correct answer, I will still take off points. The 1 and the e are limits with respect to x. Your integral is now in terms of u. The 1 and the e do not apply here. Now let's finish up the integration. You should have memorized that the integral of tangent is the natural log of the absolute value of secant. It's a definite integral, so no plus c, but I still don't have those limits, so I'm going to do my little asterisk thing. Then just like always, when I did u substitution, I'm going to go back to the original variable. And u is equal to the natural log of x. So I'm going to have 4 over pi times the natural log of the absolute value of secant of pi over 4, natural log of x. Now evaluate it from 1 to e. And now I can do the evaluation. So pi over 4, and we'll see if I can write small enough to get this here, natural log of secant of pi over 4, natural log of e, minus the natural log of the absolute value of secant of pi over 4 times 1. Absolute value in parentheses. And so, continuing on, that's pi over 4, natural log of secant of pi over 4. Remember, the natural log of e is 1. I made a mistake right here. Let's see if I can write a little bit smaller and get it in here. This is how you know it's live. I make mistakes. So minus the natural log of the absolute value of secant of pi over 4 times the natural log of 1. There we go. Pi over 4. Then the natural log of 1 is 0. So I get minus the natural log of secant of 0. And then keep going on that. So that's 4 over pi times the natural log. Secant of pi over 4 is square root of 2. Look it up. Minus the natural log and secant of 0 is 1. And again, if you're having problems with that, change it to sine and cosine. Secant of pi over 4 would be 1 over cosine of pi over 4. That'd be 1 over square root of 2 over 2, which simplifies to square root of 2. Secant of 0 would be 1 over cosine of 0. Cosine of 0 is 1. 1 over 1, 1. And again, that 0, natural log of 1 is 0. That's going to creep up over and over again. So I got 4 pi natural log of square root of 2. And that's a perfectly good answer. There are games, log games, you can play with that natural log there. I do not care if you play the natural log games. You could do this, and I don't care at all if you could do this. But you can say the square root of 2 is 2 to the 1/2. Then log games, that 1/2 can come down in front. And so what we get, 2 over pi natural log of 2. Yeah, you couldn't pay me to care about that. But it wouldn't surprise me if the answer in MyLab Math actually did that. And if you type in this answer, it wants this answer, change them both to a decimal. If they're the same decimal answer, just write me and I will credit your assignment with that. That I don't care if you do that. But there we did a u substitution, doing it pretty much the same way we always did use substitutions, substituting back to the original variable, then plugging in the 1 and the e. And so that's one way to do it. Do your u substitution just as normal, get your answer in terms of u, switch back to x, and then use the original limits of integration, plug in and do your arithmetic. That is one way to do it. I don't think it's the easiest way to do it. So we're going to do it again. But this part right here, do not have limits with respect to u. we're going to get limits with respect to u, and I'll do that in the next video.